We hereby present the improvement of the ventilation system of Bogala mine, which is to be worked for a depth of 500 meters. This project is a ventilation on demand. Bogala mine is spread over a fairly large area, and there are many crosscuts, drives, ventures and rises in the mine. The ventilation system of this mine is quite complex, and due to its current conditions, not all areas are ventilated to the required extent. Some areas are ventilated more than necessary, while others are not. However, people work in almost all of these places, and those working in some places do not receive sufficient airflow to remove the dust and harmful gases generated after an explosion. Due to this, the possibility of serious diseases like carbon monoxide poisoning, lung cancer, chronic bronchitis and pneumonia is high for the workers. This is a life-threatening condition. To avoid this, we have redesigned the ventilation system here. Simply put, air is supplied in the right quantities to the right places, minimizing energy loss and ventilation loss.
For this, we use the Design software to create a digital twin of it and use it to create several modules to provide air to the required locations. Now, you can see a description of it. Before the optimization, the ventilation network at Bogala mine was unbalanced. At the 170 fathom level, the airflow was clearly insufficient. Meanwhile, the booster fan at 275 fathom was increasing in volume, but overall efficiency was poor. In this situation, the main exhaust fan was drawing about 40 kW per hour to move approximately 1500 cubic meter per minute, an inefficient operating point. The solution was a targeted reconfiguration. The booster fan was moved to the 205 fathom level and its flow path was changed to better support the upstream district. In parallel, air control was tightened by adding doors, installing doors with regulators and fine-tuning them so that air only goes where and when it's needed. The results were immediate. The 170 fathom level now receives strong, reliable airflow and previously underventilated areas are properly supplied. The 275 fathom booster now provides just a boost needed, no more, no loss. Most importantly, energy performance have improved. The main exhaust fan now maintains the mine at 1338 cubic meter per minute with a power draw of 28 kW per hour and can operate as low as 1172 cubic meter per minute at 20 kW per hour when conditions allow. That's a significant reduction in power for a healthier, better controlled underground environment. In addition, the Design software can be used to control the electric roller doors and fans installed in the mine, and we obtain information about real-time data in the mine. However, this license costs 10 million rupees, and as a solution, we have built a mine control system. Using that system, we can control the doors and fans, monitor real-time data. In addition, by comparing the data, the speed of the fans is automatically changed, maintaining the balance of the mine's ventilation system and automating the doors. Now you can see it. The special thing here is that there are limitations in benzene depending on the amount paid, and there are no such limitations in our control system.
Now I will briefly explain the application we developed for the ventilation on demand system. This application is designed for two types of users, operators and administrators. Everyone can log into the system, but only administrators have access to the setting and configuration panels, while operators can only use the monitoring and control function. Main function section of the application, the system is divided into 4 key parts. The first part is manual control panel. In here, users can manually control any ventilation door or fan in the mine. It is mainly used during maintenance, emergency or when automatically door need to be override. The second option is run operation system. This section displays all the previous save operational setup. A setup defines which doors are open and what fan speed are used for the specific shift or working condition. The third option is edit operational setup. In this section, admin can create or modify setup. They can select which door should remain open or closed, set fan speed percentage and save the configuration for further operations. Next one is event log. This keeps a record of all activities inside the system. It shows who logged in, what action they performed and at what time, ensuring full traceability and accountability. In the settings section, admin only the setting menu is restricted to the administrator and include 4 subsections. The first one is user management. In this, we can add, remove or assign a role to the users. The second one is device configuration. In this, we can add new register doors, fan, control or sensors. The third option is MQTT settings. In this, we can set up broker details for communication between underground device and the central system. Next one is log management. In this, manage data storage, backup and clear all logs. In this system, we have additional key function is emergency button. Instantly open the all ventilation door in case of fire or network failure. And also there is a lock button, safely exit the system will prevent unauthorized access. When we execute the command, they are go through the MQTT broker. Each door or fan also connect to this broker. Then the command are transferred both directions through this broker and run as the command.
This part of the interface provides a detailed description of the real-time data. The measurement panel also shows a comparison of the real-time data provided by the Arduino kit for each fathom level with the data we prepared using the benzene software. The importance of this is that we can update whether the ventilation system of the mine is working properly. The gauges panel provides a graphical description of it, and the charts panel provides a comparison of the current and previous conditions. Finally, we designed a bell mount for a booster fan to see if it could replace the main exhaust fan, which uses more energy. According to the results we got, it can be done. The CAD design of this bell mount is unique in that its discharge coefficient is 0.9929. You can see the calculations here. The confirmation obtained from the CFD analysis of this bell mount shows that a large energy saving can be achieved by connecting this bell mount and operating the fan. The result of all this was that the life risks that the miners had so far were reduced and they received a more favorable and comfortable environmental condition. In addition, the annual electricity consumption was reduced by 41% from 184.3 megawatt to 110.02 megawatt. We are happy to be able to contribute to energy conservation in the mine as well as in the country. All this was done at an initial cost of only $5,750.